Hello, in this lesson we are going to look at exponents. Again, there will be some review from what you've learned in previous grade for exponents, so just make sure that everything I say makes sense for what you previously know. And we're going to move on and maybe look at something that might be new, like negative exponents as well. Recall some of the basic exponent laws. So if you're multiplying a couple of powers together, like a to the m times a to the n, you are going to add the exponents. Maybe I'll just highlight the exponents. So multiplying, we add the exponents. If we're dividing a to the m divided by a to the n, we subtract the exponents. Notice how the bases have to be the same in each case. And if we have power over power, so in other words, a single power, we only have a here once, and it's all raised to the exponent n, then we multiply the exponents together. So that's all from grade 9. But and you probably already know zero exponent from before now as well. But we're going to keep going. We're going to review that, and we'll also look at what negative exponents mean. So let's just consider this pattern going on here. If we've got the number 1,000, we could write it as 10 to the 3, right? If we have the number 100, we could think of it using our division exponent law as 1,000 divided by 10. So 10 to the 3 is 1,000. We know that 1,000 divided by 10 equals 100. But we could also use our exponent laws. We know that 10 to the 3 divided by 10 to the 1, we could just subtract the exponents and we get 10 to the 2. So we're just illustrating. The point of doing this is just illustrating how we can see a connection between different multiples and the exponents on them, so that we can, once we get to some we don't know, we'll know what to do. Well, if we can compare the number 10 to 100, we know that 100 is 10 to the 2, and so if I divide 10 to the 2 by 10, then I get 10 to the 2 minus 1 and 10 to the 1. So again, we can write exponent 10 the number 10 as 10 to the 1. And then if we just keep doing that, the next one would be 10 to the 1 divided by 10 to the 1, which gives us 10 to the 0. All right, so if I divide 10 by 10, in other words, dividing 10 by 10 with exponents there, we know that we could use the exponent laws to just subtract the exponents. So 10 to the 0 equals 1. And I think, like I said, most people know already that anything to the exponent 0 equals 1. So we're doing examples with 10 right now. 10 is our base, but this would apply for other bases as well. I didn't mean to erase that part. So 10 to the 0. Well, what about 0.1? Well, we can get 0.1 by taking the number 1, which could be written as 10 to the 0, and dividing the number 1. Maybe I should be writing this rather than just as powers. Let's do this. So we know that 1 divided by 10 equals 0.1. I could rewrite 1, though, as 10 to the 0, as we just saw. I could rewrite 10 as 10 to the 1. So if I want to use the exponent laws, I could subtract. That would be the same as 10 to the 0 minus 1, which would actually be 10 to the negative 1. So 10 to the negative 1 is equal to 0.1. And if I was to take 0.1 and divide that by 10, that would be the same as 10 to the negative 1 divided by 10 to the 1, which would be the same as 10 to the negative 1 minus 1 when I use my division rule, and I'd get 10 to the negative 2. So it would turn out that 10 to the negative 2 is equal to 0.01. So maybe you can see a pattern going on here. 0.001 is the same as 0.01, 1/100th, divided by 10 again, which is the same as 10 to the negative 2 divided by 10 to the 1, which is 10 to the negative 2 minus 1, which is going to give us, you probably guessed it, 10 to the negative 3. So 10 to the negative 3 equals 0.001. So negative exponents, it turns out, don't give us negative values. They give us they give us very small values. And in fact, we could think of this as 10 to the negative 1, we can think of it as 1 over 10 to the positive 1. We can think of 10 to the negative 2 as 1 over 10 to the positive 2. 1 over 10 to the positive 3. So 1 over 10 to the 1 is just 1 over 10. 1 over 10 squared is 1 over 100. So it's giving us these small numbers. That's where the negative, or what the negative exponents do. So let's go through a couple things just to make sure that you're on board. We just used a base 10 for this example, but we could use any kind of base. So 5 to the exponent 0 is going to equal 1, because anything to the exponent 0 equals 1. Negative 7 to the exponent 0 is going to equal positive 1, because anything is equal to 1, and right now that 0 is on the whole bracket, including the negative sign. It makes it positive 1. But compare that to part C, where there's no brackets. That means that 0 is only on the 7, which means that the minus sign stays there, and then we put 7 to the 0, which gives me 1, so altogether it becomes negative 1. Decimal, that's on the whole decimal, that just equals 1. And if it's a variable, it still just equals 1. Anything to the exponent 0 equals 1. But this one is different, not because the rule is different, but because the negative sign is not affected by that 0. If it was, it would have become a positive as well. So here's a couple of more exponent laws that we can add to our arsenal based on what we just saw. Anything to the exponent 0 equals 1. Anything to a negative exponent equals 1 over that anything to that same exponent. So a to the negative n would be 1 over a to the positive n. 2 to the negative 3 would be 1 over 2 to the positive 3, and so on. So let's work with a couple of negative exponents. That means that 5 to the negative 2 is 1 over 5 to the positive 2, which I should write as 1 over 25. 5 to the negative 3 is 1 over 5 to the positive 3, which I should write as 1 over 125. Negative 7 in brackets to the negative 2 is the same as 1 over negative 7 to the positive 2. And a negative number to an even exponent, if the negatives inside the brackets, becomes positive. So negative 7 times negative 7 is positive 49. Whereas D part, again, doesn't have the brackets. That means something different. It means the minus sign stays out front. And I do 1 over 7 squared like this. So make sure you see the difference. That minus sign is unaffected by the exponent because it's not in brackets. So we have the difference between 1 over 49 and negative 1 over 49. X to the negative 9 would be 1 over x to the positive 9, and I can't simplify that any further. Here's a few more rules which you may or may not have worked with before. If we have a multiplication, so in other words a product, inside brackets or being affected by an exponent anyway, it's like the distributive law. So this AB is being affected by this exponent n. In other words, n, it's like distributive law. We're going to apply that exponent n to the a and to the b individually. So that's how I get a to the n and b to the n. To see it in practice, 2x to the 5, all raised to the exponent 3. I'm going to multiply that 2. I'm going to raise that 2 to the exponent 3 as well as that x to the 5, because there's two different parts. Maybe instead of doing it in one single highlighter color like I did here, I'll show the two different parts. So the 2 is one part and the x to the 5 is another part. They're they're each being raised to the exponent 3. 2 to the 3 is 8, which is where we got this from. And x to the 5 all raised to the 3, we know we multiply our exponents together. And likewise, if we have a quotient, a division, we're going to raise the top and the bottom to the same exponent, n. So a over b to the n, if it's in brackets, becomes a to the n over b to the n. But it has to be in brackets. If it's not in brackets, then the exponent isn't on all parts. It's only on what it's beside. But in this example here, we can think of the x being raised to the exponent 3 and the y to the 4 being raised to the exponent 3. So that's why I get x to the 3 on the top in that example and y to the 12 on the bottom, because I'm doing 4 times 3, multiplying those exponents together. And then we can combine those with negative exponents as well. If something's already a fraction, let me backtrack for a second. Just for negative exponents, we saw that we can write it as 1 over, something like this. A to the negative n is same as 1 over a to the positive n. But if it's already a fraction, that would mean I'd do 1 over 1/2, which is really awkward. 1 over 1/2 actually simplifies down to 2. The shortcut is, if it's already a fraction, just flip the fraction upside down and then drop the negative sign. That would be the same result as if I did 1 over 1/2 to the exponent 2. So, obviously 2 over 1 is just 2, so that's going to end up equaling 4. This one's also negative, so I'd flip it upside down first. And then I'd apply the 2 to the top and to the bottom, so that would be 3 squared over 2 squared, which equals 9 over 4. And then this one, I'd flip it upside down. I'd have 2 over negative 1 to the positive 3. And again, I'd apply that positive 3 to the 2 and to the negative 1. That would give me 2 times 2 times 2 is 8 over negative 1. Negative 1 times itself 3 times is going to be negative again. But it's just still going to be 1. So I'd simplify it a bit further. To finish off, I'd write it as negative 8. So here's a few examples where we're putting a couple of these things together. Remember, order of operations still applies in everything we do, even if we're doing exponent laws. So if I'm doing powers of powers, which involves multiplying, and I'm doing multiplying of powers, which involves addition, the multiplying comes before the addition part. So here's a couple of powers being with the same base being multiplied together. So it's to simplify and write with positive exponents only. Okay, so you'll often see this instruction about writing with positive exponents only. So what you do in this case is you simplify first, forget about that part of it, and then when you're done, look and see if there's any negative exponents, and if there are, then you deal with them then by turning them into fractions like we've done above. So I'll start by just multiplying these together. So 2 to the negative 2 times 2 to the negative 9 means I'm going to add those exponents and end up with 2 to the positive 7. So no need to do anything with negative exponents. And it doesn't ask me to simplify it any farther, so I'll just leave it as a power. In this one, I would simplify the top first. So 3 to the negative 2 all raised to the exponent negative 2 means I'm going to multiply those exponents together first. And so then I'd have 3 to the 4 over 3 to the negative 3. And I would write this one out to make it as clear as possible by writing it as a division. It's going to be 4 minus negative 3. The minus here is because it's a division, whereas the other minus was just the minus sign in front of the negative 3. So that actually becomes 4 plus 3, and so that would be 4 to the 7 when 3 to the 7 when all is said and done. Again, I don't need to go any farther with this one. For C part, I would simplify the fraction. Maybe I'll just leave this for now. And I'd simplify the fraction by flipping it upside down because it's already a fraction and it's to the negative 1. So I'd do it as 11 over 11 to the 8 over 11 to the 3, all to the positive 1, which doesn't do anything. I'd simplify what's inside maybe the brackets, since it is inside brackets. I would have 11 to the 8 minus 3, so it would be 11 to the negative 4 times 11 to the 5. And then I'd add those exponents together. Negative 4 plus 5 gives me 11 to the 1, which I just write as 11. So it turned out, in this case, there was no need to do anything with changing them from negative exponents to positive exponents. But if I'd gotten to the end and did find that I had a negative exponent left, I'd have to turn that part into a fraction with 1 over, which I'm sure will come up in some future questions.